This video is going to go through basic rules of indices to begin with, and then we'll look at some harder examples a bit later on as well. So first of all, straightforward indices questions would be something like this. So to simplify things like that, where they're times together, and when you times things like this with the same what we call base number, where you can see it's A here and A here, you just add the indices together. So 4 plus 7 is 11, so this would be A to the power of 11. So another example, if you had B to the 7 times B to the 3, and that would be B to the power of 10. And then sometimes they might bring numbers in front of that, so it might be like 5C to the power of 6 times 4C to the power of 3. So if you get something like that, you would do the 5 times 4 is 20. And now again, you're still timesing these together, so therefore we want to add those indices, so it would be 20C to the power of 9. Now just something to watch out for is one like this, where there might be no power on this one here. So it's really easy to think that that power is 0, but anything to the power of 0, which we'll look at later, is actually 1. So this D does actually have a power of 1, and you need to remember that when you add the indices in a minute. So you would do 6 times 2 is 12, and then you would need to remember that this is 1 plus the 3 makes a power then of 4. Okay, so just watch out for the ones that don't have a power. That means the one that the actual power is 1. Right, so in the same kind of way then, we can probably do dividing now a little bit quicker. So say if you had something like this, where it's a division, if it's dividing, then that just means you're going to take away the indices. So 7 take away 4 is 3. And then we're going to try ones with numbers in the front. So say you had this. Then you would do 8 divided by 2, because this time it's dividing. So 8 divided by 2 is 4. And again, take away the indices. Well, 6 take away 4 is 2. And I'll just do one of those ones again where it doesn't have a power, just to show you one more time. So something like this, you would do 14 divided by 2 is 7, and then it looks like 7 take away nothing, but remember that is actually a 1, so it's 7 take away 1, which is 6. So it would be 7b to the power of 6. So quite often they might do ones like this where they say to write as a single power of 5, for example. It could be anything, I've just chosen 5. So it might be an expression that looks like this. So with this kind of thing, you just need to work out the top, work out the bottom if it needs working out, and then do the division after that. So for this one, we can do, we're timesing here, so I'm going to add those indices together. So 3 plus 9 is 12, so it would be 5 to the power of 12. I'm just going to keep this one, there's nothing to do on the bottom, just keep it as 5 squared. I don't want to actually work out what these numbers are. If this was on a non-calculator paper, obviously 5 squared is quite easy, but you wouldn't be able to do that without a calculator anyway. And the fact that it's saying to write it as a single power of 5, I don't need that over, single power of 5 means that actually we want our answer to be 5 to the power of something. So now I'm going to do a division, which means I need to take away the indices because it's dividing. So 12 take away 2 is 10, so this would be 5 to the power of 10. So moving on then, those are kind of like basic indices that you should be fairly good on, maybe just need a quick reminder. Moving on to more complicated rules. So the first one is one that I mentioned a little bit earlier, in that anything to the power of 0 is 1. So for example, if you've got a to the power of 0, I don't know what it's going to be, 1 second. Anything to the power of 0 is 1. So even if it was 715 to the power of 0, that would still be 1. So anything to the power of 0 is 1. You also need to know negative indices. So say if you had 7 to the power of minus 2. So when you get a negative indice, the first thing I would do is put 1 over it like this. You're going to keep the 7 as 7, but instead of making the power minus 2, I'm now going to make it positive 2. And now 7 squared, if they actually wanted you to work out what this is, 7 squared is 7 times 7, 49, so this would be 1 over 49. So I'll obviously do a few more for you. So if you had 5 to the power of minus 3, then you would do 1 over it. You're going to make the power positive, so it would be 5 to the power of positive 3. And remember, 5 to the power of positive 3 means 5 times 5 times 5 again. So 5 times 5 is 25, times another 5 is 125. So it would be 1 over 125. Sometimes you might get a fractional one to a negative power, so something like this. So if it's a fraction to a negative power, then you can do 1 over it, but it kind of makes it more complicated than it needs to be. It's probably easy just to remember that you flip the fraction over, so it becomes 3 over 2, and then make your power positive again. So it'd be 3 over 2 to the power of 2. So that just means that you need to square the 3 and square the 2 as well. So it would be 3 squared, which is 9, because it's 3 times 3, over 2 squared, so 2 times 2, which is 4. So the answer would be 9 over 4. You also need to know about fractional ones, so things like this. So say if it was, actually I'm not going to start with that, we'll start with 16 to the power of a half. So with fractions, in the powers, you need to look at the bottom number here, and that tells you what kind of root it's going to be. So it's either going to be, in GCSE, a square root or a cube root. So if it's a 2, then that would be a square root. So you would square root the 16 to get 4 like that. Now if it's a 1 on the top, you don't need to worry about that, you just do what the bottom number says. We'll have a look at when the top number changes in a minute. So if you had, let's say 27 now to the power of a third, so third means that you're going to cube root it, so it's a 3 on the bottom. So the cube root of 27, which you would be expected to do that without a calculator. So you're looking for a number that when you times it by itself 3 times, you get 27. So for example, 2 times 2 times 2 is 8, whereas we're looking for 27, so it's going to be bigger. So if we try 3, 3 times 3 is 9, and when you times that by 3, you then get 27. So the cube root of 27 is 3. If you have a, let's try a fraction to a fraction power. So again, still check the bottom number. That means it's a 2, so it's a square root. So you would just square root the 4 and square root the 9. So that would be 2 over 3. Right, so ones where you don't have a 1 on the top. So this is where now it does start to get a little bit more tricky. So say if you had 8 to the power of 2/3. So you check your bottom number, which is a 3. So that means that I want to cube root it. So the cube root of 8 is 2. But I've still got this 2 up here, and that means it's to the power still of the 2. So 2 squared is 4. So if we do another one of those, so say if it was 16 to the power, this time we'll make it 3 over 2 rather than 2 over 3. So remember, the bottom number tells you what kind of root you want to do. So it's a 2, so it's a square root. So square root of 16 is 4, and then the power here is 3. So 4 to the power of 3 is 4 times 4 times 4, which is 64. Trying to think if there's any more of those. I think that's probably it for the fractional ones. So what they could do now is a mixture of both. They might do a negative fraction like this. So I would deal with the fact it's negative first. So that would mean that we do 1 over it, like we did on the previous ones. 1 over it, and we're going to make the power positive. So it'll be 1 over 9 to the power of positive a half. But now I need to deal with the fraction. So check the bottom number, it's a 2. That means I want to square root it. So it'll be 1 over the square root of 9, which is 3. I don't need to do it to the power of anything because it's just a 1. 3 to the power of 1 is just 3. So my answer is 1/3. So if I had, let's say, 27 to the power of minus a third. So again, it's negative, so let's deal with that. So it would be 1 over 27, and now we make it positive. So 1 over 27 to the power of positive a third. Fraction, check the bottom number, 3, so cube root of 27, which would be 3. Right, let's make it even more complicated. So let's do 25 to the power of minus 3 over 2. Let's see how that goes. So it's a negative, so let's deal with that. 1 over it, make the power positive. After that, it's a fraction, 2 on the bottom, so I need to square root. So when I do the square root of 25, I get 5, but I've also got the power of 3, so I'm going to have to work out 5 to the power of 3, so 5 times 5, which is 25, times 5 is 125. So those are kind of like dealing with indices questions that you quite often get in the exam. They're generally going to be on the non-calculator exam, because there would be no point just typing that in on a calculator and getting marks for that. So that's going to come up on paper 5, where you are not allowed a calculator. Now the other kind of questions that they can ask are more algebraic ones. So this is really now moving on to more like grade 7, 8, 9 questions, where it's quite difficult algebra. So it might be something like simplify something like this. I think what else they might do. We'll try this one for now. So something I should have mentioned previously is that when you've got brackets like that, you times those indices together. So 3 times 2 is 6. And now we're multiplying, so you're going to add those indices together. So 6 plus minus 4, that's like 6 taken away 4, so that would give me a to the power of 2. I'm trying to think of some more that they might ask. So say if you had a to the 3 to the power of 1 over 4 times a, let's go for, right, so this one here. I don't know what I've done, it's probably a really horrible question. So here we're going to times the indices. So 3 times a quarter would be 3 quarters, times a to the power of a third. And now this would bring in adding fractions, which is another topic, and that's quite often what they like to do in GCSE to stretch the top end students, is to mix topics up. So we'd have to do 3 quarters plus a third without a calculator. So 4 and 3 both go into 12, so I'm going to make the denominators 12. This one has been times by 3, so I'm going to times that by 3 as well, so that would be 9 over 12. This one's been times by 4, so I'll times that by 4 as well. Sorry, I was thinking of the answer, so that would be 4, and then the answer would be 13 over 12. So therefore this would be a to the power of 13 over 12, like that. Okay, so the next question then is a proving question. So again, if it's a proving one, you're going to have to show this algebraically and not just try numbers and putting them in. That won't actually prove it. So this has got 1 over a to the 4, so I know that I can rewrite that as a to the power of minus 4, because that would mean 1 over a to the power of positive 4. So I'm going to rewrite that using indices. And this one here, well, if it's brackets, remember we times those together, so 2 times 2 is 4. So then when I'm timesing, I'm going to add these indices together, so minus 4 plus 4 is 0. And then we know that anything to the power of 0 equals 1. So questions like that again come up fairly often, but like I say, you're looking more at grade 7, 8 or 9 for those kind of questions. The final one that I'm going to do is a question like this, where again it will be write as a single power of 5. So that means we want our answer to be 5 to the power of something, so just bear that in mind. We're not trying to actually work it out, just to keep it as a power of 5. So say if you had something like this. And this again would come up probably on a non-calculator paper. So if it's a single power of 5, we want to think about how can we write any of this as powers of 5. Now even if you can't do the whole question, it's worth just picking out bits that we can do. So 125, you need to think, what is that as a power of 5? So 5 to the power of something is 125. Well, 5 squared is 25. And 5 cubed would be 125. So I'm going to say instead of 125, it will be 5 cubed to the power of 7, like that. And again, this one here, how can we write this as a power of 5? Well, if it's 1 over something, it must have been a negative power, and it's 5 to the power of 1 here on the bottom, isn't it? So this would be 5 to the negative 1, and then that's squared as well. So I've just rewritten them using indices. So now I've got the brackets, so that means I'm going to times these together. So 3 times 7 is 21, and minus 1 times 2 is minus 2. And now because I'm timesing, I'm going to add these together. So 21 plus minus 2 is then going to give me a power of 19. So my final answer would be 5 to the power of 19. So I might just do actually just one more of those. So this time we're going to write it as a power of 3. So let's say the question was, let's think, 27 to the power of 8 times 1 over 9 to the power of 5. So let's go for this one. So this time we're trying to write it as a power of 3. Look at the numbers here, think how can we write these as powers of 3? Well, 27 is 3 cubed, isn't it? So I could write 3 cubed instead of 27, and then that's to the power of 8. Right, the 1 over means it must have been a negative indices. Now 9 is 3 squared, isn't it? So that's the same thing as 1 over 3 squared. So if it's a negative indices, instead of positive 2, it's going to be minus 2. And then that's to the power of 5. So now times these together. So 3 times 8 is 24. And minus 2 times 5 is minus 10. So now because I'm timesing, I'm going to add these together, but because this is negative, it's like 24 minus the 10. So my final answer would be 3 to the power of 14.